start with the product rule. This is how it's written in your book. Oh, I should be careful here. You see that thing that says d dx? I don't know if you've seen that yet in this class, have you? Okay, let me read that to you. The way you read that is the derivative with respect to x. And some of you are saying, what are you talking about, Paul? What I'm saying is, for all my functions, the input that I'm thinking of is the variable x. Some of you are going to be taking Applied Calc 2. By the way, I just found out I am teaching that this summer, it looks like. Okay, Applied Calc 1 and 2. And when you take Applied Calc 2, you use the back half of this book. Sometimes the functions, you have more than one input. You might have x, y, and z, okay, as inputs. And then that's when this notation is really helpful, because I'm saying which one's the input. But basically, for you guys, it means derivative. Okay. Suppose you have the derivative of two functions, and if the functions are next to each other, what does that mean I'm doing to the two functions? Multiply. It's not like you could just take the derivative of each of them. Actually, we saw that last time. Didn't work. I forget who had me. Somebody not here today, but they said, hey, can you just take the derivative of each? No, it doesn't work. It's f prime g plus f g prime. Okay? And I guess I need to show you an example to really make it make sense, and then we'll come back to how it works. So I think this is a nice example to start with. We're going to find an equation of the tangent line to the graph of this function. Okay? And then I gave you what x equals also. So let's do this first, and then I'll go back, because I am going to go back later. Okay? But right now, let's just write this down. X cubed minus 3x plus 1 times x plus 2. So that's my function. And I'm saying that that function goes through the point 1, negative 3. Okay? And then you notice I wrote down a different version of the product rule that I think is a lot simpler. Actually, I'm going to go to my paper now so you can kind of see what I'm writing. And that's one of the reasons I didn't want to go back. Is because when I think of the product rule, here's what I think of. The product rule, if you have a product, u, v, and by the way, anytime I write u or v, I'm really saying u of x, v of x. Those are functions of x. And if I put that little prime, what does that mean? Derivative, right? So what the product rule is, take u prime times v plus u times v prime. That's the product rule. So I'm going to use that product rule here. And then I'm going to try and find the equation of a tangent line. Okay, so basically the problem says, find the tangent line through 1, negative 3. By the way, is this point really on the graph? I guess I could figure that out, right? What would I have to do? F of 1. Do you guys understand how I would do that? No? Let me show you. Here's the function, right, guys? So if I did f of 1, what does that mean I'm doing? Put a 1 in for the x, right? I'd get 1 minus 3 plus 1, right? Times 1 plus 2. Wouldn't I get negative 1 times pi? It works, right? I really do get what? Negative 3. I just want you to see that really is a point on the graph. Does that make sense? Okay. So what's my first step? If I want to find what the tangent line is. Yep.
We want to find the derivative of those two functions.
Well, we want to find the derivative of this big, ugly function f. And it's interesting because you said there's two functions, and you're right. You said you're thinking of this first function. I'm going to call this guy u, and I'm going to call this guy v. Okay? U and v. So watch how I do this. Maybe this will help you guys. I'm going to say f prime of x equals, okay? So the first thing I see is it says u prime. So do you know what I'm going to put where it says u prime, what I'm going to put for my derivative? 3x squared minus 3, right? And then v, so I'm going to write x plus 2. Does that make sense to you guys? Plus, because there's a plus sign. What am I going to write next? It says u. What are we going to write? X cubed minus 3x plus 1. And now, what's v prime? Well, yeah, because what's the derivative of x? 1. And what's the derivative of 2? Does that make sense to people? We did that last time. The derivative of x is actually just 1. But the derivative of any constant ends up being 0. You guys with me? Now, could I simplify this? I guess I could. I could have simplified the thing at the beginning and not used the product rule. But see, there's no need. I have a function now that I can use. Because what I want to do next is find, say, the slope of the tangent line. So what do you think I'm going to do? See, my slope m is going to be f prime of what number? 1. Right? You always take the x value. And so that means everywhere here that I see an x, I'm going to put a 1.
So technically right now we have the derivative, it's just not a simplified version.
That's right.
Okay.
This is the derivative. Now why simplify it? You don't have to, right? I mean, here I get 3 times 1 squared minus 3. And here I get 1 plus 2. And here I get 1 cubed minus 3 times 1 plus 1. And here I get 1. So look what that equals. First of all, what's this? That's 0, right? 0 times 3 plus, let's see, 1 minus 3 is negative 2 plus 1. I think I get negative 1, right? So I think you just get negative 1. Because you get 0 plus negative 1, so you get negative 1. So, we found the slope of the tangent line, but we have to find the equation of the tangent line. Tell me what form to use. Okay, so let's write it down. Y minus y1 equals m times x minus x1. We know what m we're going to use. Negative 1. What about the other stuff? So that 1 up there, that's my x. So this is going to be x minus 1. And I heard someone say y plus 3. Why is it y plus 3? Because we're doing minus negative 3. So this is an answer if you want. Okay? If you wanted in slope-intercept form, you could do a little more work. I guess you'd get y equals negative x minus 2. But I'm fine with this answer in point slope form. Either way. Okay? You guys are good there. Let's go back to the PowerPoint. Oh yeah, these problems are right from your book. I thought that this might be good to do next. You guys have your books that you can open up to the section 3.2. These functions are, I want to do applied calculus here, guys, not just functions. I want to take them and put them into action. So here's two functions, problems 63 and 64, and I thought we would work those out next, okay? I think these are the problems that could be harder. You know, you could do the basic computations, but then can you interpret what's going on? So it tells me that monthly sales of the Bluetooth headphones, this is a sales function, monthly sales function. It's modeled by 30t minus t squared over 2. And it says 0 less than or equal to t less than or equal to 5. What does it say t is measured in here? So t is a number of months that they've been selling them. And then q of t is in hundreds of headphones. Okay? So that's important to understand. If we're going, because they're going to ask me to do some interpreting here in a minute. All right? So I could probably sketch a graph of that. I think I will. I'm going to go ahead and take my calculator out, try and do this. Let's see. Go to the y equals screen, clear some of this stuff out. So it says 30. Now I don't have a T button. I'm going to use this X button up here. It says T also, but 30x minus x squared divided by 2. Oh, I better change my window, right? What should I change my window to? Oh, we could do the standard. This is the standard. Let's see what happens. I don't really see it. I thought that would happen. Maybe there's a better choice. Well, first of all, the inputs are between what and what? Okay, that may help. Change the inputs to go from 0 to 5. Now the outputs, boy, how many hundreds of headphones do you think we're going to sell? Well, definitely more than 0. Here, let me graph and see if I can see anything. Ooh, you see what's happening? We're selling a lot more headphones than I thought we would. A lot more than 10. All right, give me a new Y max. What do you guys guess? Take a guess. 100? If it's wrong, we'll adjust again. And this is what you have to do. And I'm going to put a mark every 10. No, I'll put a mark every 50 so I can count. Let me graph. Okay, that's not bad. So this is the monthly sales figure. So the next function they give me, they say P of t. What does this represent, guys? Read carefully. Retail price. So let me ask you this. Can you guys tell me how much the headphones cost initially when they were first put on the market? Well, P of t is the price. Is it measured in dollars? Does it say dollars? Yeah. So why you say $220? Because P of 0, for instance, is 220, right? By the way, do you think that the price is going up or do you think the price is going down? I think it's going down too, because it seems like we're going to be subtracting something once t is bigger than 0. And actually, I guess I could graph that. I could say, all right, let me go to the y equals screen, and let me type in 220 minus x squared. And I could graph that in the same window. Ooh, I don't really see it. Oh, I know why. Look at my window again. What's the y max right here? 100. I better make it at least 220. Why don't I make it 250. And press graph. And I'm putting a mark every 50 the way I did this. So here was the sales function. And what's that one up top? What's that? That's the price. So as the months have gone by, we've been selling more and more, and the price is coming down. Okay? So that's what it tells me. So now, the question says, A, evaluate Q of 3 and Q prime of 3 and interpret each. Oh, wait a minute. I have a little bit of work to do here. I have Q of t. Let me write down Q prime of t. What's Q prime of t going to be? Well, what's the derivative of 30t? Yeah, it's just 30 times 1, so 30 minus. Now, when you do Bing, you're going to bring the 2 down, but you know what it's going to do then? It's going to cancel with that 2. Does that make sense to people? It's going to be 30 minus t for the derivative. Okay? Let's see if you guys can do. Well, I had negative t squared over 2, right? Let me write it again. Here's 30t minus t squared over 2. That was my p of t. So when I do p prime of t, you understood the 30, okay, right? What would I do? I would do Bing and bring the 2 down, t to the first, but then there was a 2 down here, and so it canceled, and so that's why it was just minus t. Could you guys all write down what p prime of t is? Well, it's funny because what's the derivative of 220? That's a constant, so that derivative is 0. What's the derivative over here? Negative 2t. All right. So problem 63 wants me to use these functions, do some computations, and interpret. And again, that's what this class is about. Can we interpret what's going on? So, the first thing it asks me for is Q of 3. Q of 3 equals, and I guess you'd have to work out what this is. I guess I could do it on the calculator. I mean, 30 times 3 is 900. You guys could get it probably faster than I could, but I'm going to do it on the calculator. Second, calculate a value. You just type in 30. Enter. Oh, why didn't that work? Because it didn't say to do 30. It said what? Sorry about that. Just 3. Enter. Okay. So what's it say? 85.5. Hey, is that Q or is that P? That's Q. Q of 3 is 85.5. How do I interpret that? So I would say this. After 3 months, the number sold, number of headphones sold was, what would I say? 85.5 what? 100. So how do you do that? Maybe I would say 8550, right? If you multiply by 100. So there were 8,550 headphones sold in 3 months. You guys follow? Yeah? Oh, so the next part is, let's find Q prime of 3. Well, Q prime of 3, we just do 30 minus 3, we get 27. Q prime of 3 is 27. So to interpret that, I would say, in the 3rd month, the rate of headphones sold, if you want, was, now what am I going to say? Usually we'll use the words increasing or decreasing. What are we going to say about the headphone sales here? Here it's increasing. You can see it from the picture. You can also see it because the derivative is positive. So it's increasing 27. Now here's where people sometimes get stuck. What are the units? Well, 100, right? 2,700 headphones. But remember, it's a rate, so it has to be per something. Per month, because we're measuring time in months. And that's how you would interpret that part of this. That's right. Well, it's increasing 2,700 per month. So that says next month we're going to be over 10,000. Are you guys with me? What's that? Over 9,000? Okay. What's that? Oh, I missed it. Where's it? What movie? Here we go, the P's. So what else do we have to do? We have to do P of 3. Well, that's P of 3 is up here. 220. This is all garbage. Let me get rid of this. Sorry about that. P of 3 is 220 minus 3 squared. So that's, well, 220 minus 9 is 211. So what does that mean? Oh, I know. After 3 months, what would we say? Remember what P of T stands for? Yeah. The price of the headphones. Has it gone down? Well, a little bit, right? Is $211. And now let's do the last part of this. P prime of 3 equals, well, where's P prime? P prime is negative 2t. So negative 2 times 3, negative 6. So let's talk about this. After 3 months, the price of the headphones, what would I say, is decreasing how much? $6 per month. I'll be honest with you. I feel like these problems are the ones that people need the most help with. So I'm hoping that the video is going to help all these knuckleheads that couldn't get through the snow. But I mean, you know, this is I think valuable to go through. That's just 63. I decided to do 64 also. I think it's a good problem. It continues this. So it says part A. It says, write the revenue function, R of t. Now, how the heck am I going to get the revenue? What does that mean, revenue? Why? It's how much money you're bringing in, right? You see, if I'm selling a bunch of headphones and that they each cost $220, do you see why you would multiply by 220? Right? You're going to take the number of headphones sold times the price. And I think that makes sense to most people. So, what am I really going to do? Well, the number of headphones sold is Q of T. Right? Oh, wait a minute. That's not quite true. That's almost true. The answer is almost Q of T times P of T, but not quite. There's one more thing I need to multiply by. What is it? Not yet. Not yet. I'll get to the derivative. I'm talking just to get the revenue function. You guys told me it's number of items times what?
Right.
The price per what?
Right.
Yeah, per item. Okay? Now here's the thing though, guys. Is that what these functions really give me? Is it true that P gives me the price of an item? Yes. Is it true that Q gives me the number of items? Well, it's right. We have to multiply by 100, don't we? So that's almost right. What I really want is I want R of T is going to be 100 Q of T, P of T. That'll give it to me. Does that make sense to people? Because it said hundreds of items. So for our example, let's see if I can work this out. R of T equals 100. Now let's see. Q of T. They gave me that. It was 30T minus T squared over 2. And then P of T, 220 minus T squared. Guys with me? So now, I could compute, it says to compute R of 3 and interpret. Well, I could let you guys work on that. The other thing we need is we need R prime of T. And I want to show you how I'll do that. Do you see how there's 3 things being multiplied? But this first part, isn't that just a constant? So you can kind of ignore that. Just write down the 100. And then what I'm going to do here in the brackets, well, I'm going to do what I just taught you, the product rule. We're going to do U prime V plus U V prime. And again, this is my U and that's my V. So where it says U prime, that's my Q prime, really. Q prime P plus QP prime, huh? So I'm going to write 30 minus T times, and what's V? Well, that's this 220 minus T squared. And then my U here is 30T minus T squared over 2. And then my V prime is, what would V prime be? Oh, negative 2T. So there's some work to do here still. I'll let you guys maybe simplify that a little bit. So let me do a little more then. All right? Because basically they want me to find R of 3. I know you could do that. If they said find R prime of 3, what would you do? 100 times, let's see if I could do it very quickly. What's 30 minus 3? 27. 220 minus 9. 211 plus, and then you throw the 3's in here and you get 90 minus 9 halves, and here you get negative 6. I guess you'd want to work that all out. Be a big mess. Okay, I'm curious enough to do it. So let me type that in the calculator and see what I get. I'm going to go right to like the home screen. Let me type in what I have. So I have 100. Times, and then I need a parentheses, and I need to type 27 times 211 minus, or no, plus, and then I'd have 90 minus 4.5, so that's 85.5, times, I mean, at this point, I'm just crunching it. So I'm getting r prime of 3 is 518,400. Yeah. By the way, did anybody compute r of 3? No? Well, I'm going to do that then. Oh, actually, I could do that very quickly because I did p of 3 and I did q of 3. So remember what it is. It's 100 times 211 times, and then what was q of 3? 85.5, right? So there's r of 3. I did all that. So let's see what that is. 100 times 211 times 85.5. Again, you could just plug in for t and you'll get that. What do we get? There it is. Wow. That's about $1.8 million of revenue. Because we sold, well, we sold 85,500. So we sold about 8,500 of these headphones at over $200 each. That's about $1.8 million of revenue in the third month. That's awesome. But then what does this mean? What are the units for this thing? This is dollars, just like those are dollars. That's right. The revenue is increasing that many dollars per month. So we were at 1.8 million. Pretty soon we're going to be at like 2.3 million next month. You guys get what's happening here? This is an awesome business to get into. Okay? Who would have thought? You know? Actually, I'm glad we worked that out. That was good to see. All right. Quotient rule. It's the last thing I have time for today. What do I have, 5 minutes? 4? So, the quotient rule. Please, because of the sake of time, do not write the following down. The quotient rule in your book, if you have a function over a function, instead, maybe you write this one down. What does that say? Derivative of what? High over ho. Here it is. Ho d high minus high d ho over ho ho. You may not want to write it like that on the slide, although you'll notice, see this function here, this c? That's right from your book. I'm going to go ahead and do that. That's right from page 65, or problem 65. So I'm going to finish by starting problem 65. Okay? And obviously, the quotient rule gets used if you have a quotient. So problem 65, I'm not going to say much about it because of the sake of time, but they give me a cost function. C of x is 113x over 100 minus x. And let me just tell you that they're asking me to find c prime of x. Now again, my formula, I like to write it this way. Derivative of high over ho is ho d high minus high d ho over ho ho. I mean, you could say ho squared, but ho ho is easier to remember, I think. So watch how this works. When I want to find the derivative, ho, do you know what I'm going to write? 100 minus x, because ho is the bottom one. Where it says d high, I need the derivative of what's on top. Do you know what I'm going to write? D high. Do you know what I'm going to write? What's the derivative of 113x? Nice. Then we put a minus sign. Here it says high. You know what I'm going to write? 113x. That's high. Here it says d ho. Now, do you know what the derivative of 100 minus x is? Good. It's 0 minus 1, so it's negative 1. All over ho-ho. 100 minus x quantity squared. And I'm going to have to stop because I believe we're out of time. But that is the derivative you would use for a problem like problem